Hey, Algebra 2. We're going to go ahead and do linear functions. Here is what we're going to do today or learn about. We're going to graph lines using slope and point. We're going to graph lines using intercepts. That's your x and y intercept. We're going to graph using slope-intercept form. So that is y is equal to mx plus b, something you're very familiar with. And we're also going to graph horizontal and vertical lines today, okay? So that's something we have to look forward to in this video. All right, so we're going to graph lines using a slope and a point. Now, remember, you've graphed before, right? So what you usually have done is you've used this equation to graph your slope and your y-intercept, okay? Now, you're used to that, and we'll kind of explore that a bit more through these different ways. So, for problem A and for problem B, we have a line which is explaining our slope is 2/3, and it passes through the points of 1, 1. So I'm going to go ahead and plot 1, 1 first, and then use that slope to my advantage. So 1, 1, that would be right here. Okay. So I plotted that point. I'm going to use this slope to my advantage now. Remember, this would be my rise, okay? And this would be my run, okay? It's always going to be rise over run. So I can take advantage of this point. Again, I'm going to say rise 2. So 1, 2, and then run 3. That's 1, 2, 3. Okay? And I can go the other way as well, okay? So instead of going up 2, I'm actually going to go down 2. 1, 2. And then again, instead of going right, I'm actually going to go left. So 1, 2, 3. So as you can see, I have my linear function right here. Okay? So I've graphed A using, again, my point as well as my slope as well. I'm going to do the same thing for B. So let's go ahead and do B. Again, I got a line with slope -1/3 that passes through the points of -2, 3. Okay, so -2, that's on my x-axis, and a +3, that's on my y-axis. We'll go left 2, and then up 3. So there's where my point is. So I'm done with that part. Let's go ahead and do our slope. Okay. Now the important part for this is this negative. You gotta choose a spot, right? So it could be up here or it could be down there, but not both, right? So just for this instance, I'll affiliate that negative to that 1, okay? So again, remember this is a rise and this is a run, okay? Since I'm affiliating that negative part to that 1, I'm gonna actually go down 1. So I'm gonna go down 1 and then right 3. So down 1 and then right 3. That's 1, 2, 3. Okay. And again, I can go the other way, right? I can go in the reverse. Instead, I can go a +1, up 1, and then 1, 2, 3. Okay. So my line, and it's not going to be perfect since I drew this by hand, but it should look something like this. Okay, again, it's not going to be a straight line, but you guys get the idea. Okay, there's my line for column B. All right, so now we're going to graph using, all right, so we're going to graph lines using their intercepts now. Now, you traditionally should know how to graph this, okay? And I'll do this a bit later, but I just want to show you what you probably would have done in the past is you know that this has to look like y is equal to mx plus b form, like you guys learned in Algebra 1, right? So you'd switch things around, you'd make y by itself, okay? And then put this in y is equal to mx plus b form. So you'd make this look like this eventually, and then go ahead and graph it. That's how you guys have usually done it. But today, I'll show you another method using their intercepts, okay? And this is pretty easy, and it's nice to do it, especially for problems like this where it's just a bit messy, and maybe you don't want to start changing it into y is equal to mx plus b form, because it's not necessary. at least at this point. So I've got 2x minus 3y is equal to 12. To use their intercepts, I have to find both their x, right? Our x-intercept is going to go on our x-axis. Our y-intercept is going to go on our y-axis, okay? So what you're going to do is define your x-axis. You're just going to plug in 0 for y. And to find your y-intercept, you're going to plug in 0 for x. So how this works is I'm going to find my x-intercept first. So I'm going to do my x-intercept first. Again, to find my x-intercept, I'm going to go ahead and plug in 0 for y. Okay, and I drop everything else down. What obviously happens is negative 3 times 0 is just 0. So you're going to be left with 2x is equal to 12. That means x is equal to 6. Okay? That means my x-intercept is simply just 6, 0. Okay, so let me go ahead and plot that down at 6, 0. That's 1, 2, 3, 4, 5, 6, right here. Okay? Now, to find my y-intercept, I'm just going to do the opposite. So for y-intercept, now I'm going to go ahead and plug in 0 for x. Okay, so that's 2 times 0, and then drop everything else down. Okay, 2 times 0 is obviously 0, so I got negative 3y is equal to 12. That means divide by negative 3, divide by negative 3, y is equal to negative 4. Okay, which means my y-intercept is actually 0, negative 4. I plugged in 0 for x, remember, and I got back negative 4. I'm going to go back on my graph and find 0, negative 4, negative 1, negative 2, negative 3, negative 4. Okay? And all I have to do is connect these 2 points, and I have my graph for 2x minus 3y is equal to 12. Okay, it would be nice to have a ruler here, but you guys kind of get the idea. Right? Again, my straight line is not quite straight, but you guys get the idea. I've graphed 2x minus 3y is equal to 12. But again, how you would traditionally do this in years past is you would take this graph and put it in y is equal to mx plus b form. But if you can use their intercepts, you can actually just use those 2 intercepts and graph it that way. Okay? Alright, so I've got the same situation. In the last part, I graphed this using its intercepts, right? I found its x-intercept, and I found its y-intercept. I'm going to show you the traditional way that you've probably done it in the past, and that is using, again, your best friend, y is equal to mx plus b form. Again, m being your slope, b being your y-intercept. So again, that's slope, and this is y-intercept, okay? Now, this obviously does not look like that because your y is not by itself. So that's going to be our next step. So to get y by itself, well, I'm going to move 2x to the other side. Right? I need this by itself. So that becomes, we got negative 3y, and I've got negative 2x plus 12. So it's sort of kind of getting there. But I need to get rid of this negative 3. So I'm going to divide this by negative 3, which means I need to divide this other side by negative 3. And now I've got y is equal to, well, negative 2x divided by negative 3. Negative and negative become positive. So 2 over 3x. And then 12 divided by negative 3, that's just negative 4. So let's see if we actually get the same thing. So our line, okay, should look like 2 over 3x minus 4. But again, we remember we just did this earlier using our intercepts. But again, I'm going to do this the same way. I've got my slope, my y-intercept. Okay, I'm going to point out my y-intercept first. That would be at negative 4, which again, remember that's what we got last time. Negative 1, negative 2, negative 3, negative 4 right here. And I need to go ahead and do rise and run using 2 over 3. Remember, this is rise, that's run. Rise is 2, 1, 2, run, I'm gonna run to the right 3. 1, 2, 3. And why not do it one more time, just so we have one more point. I'm gonna rise 1, 2, run 1, 2, 3. So again, notice what I have. I got the same X and Y intercepts that I had last time. All I have to do is connect my points. Okay, again, not too shabby. Again, my graph, I wrote this by hand, so it's not going to be to scale. But obviously, it looks like very similar to what we had last time. Okay, so that's how you probably know how to graph linear functions. So you're getting to know how to do this in different ways. So we're going to go ahead and graph vertical and horizontal lines. I've got 3 examples for you. I will do these individually. But they're relatively simple to do, but nonetheless, kids get this confused all the time, so just don't be one of those kids. Now, let's start with A, okay? So the A we'll put in brown. I've got X is equal to 3. This is saying 3, it's crossing my X-axis at 3, okay? So notice, here's my Y, here's my X-axis. It's going to be crossing my X-axis at 3. 1, 2, 3. So here's where it'll be crossing, and it's going to be a vertical line that we have. Okay? Going up and down forever. So this one would be our vertical line. Okay? Next one, we've got y is equal to 2. Well, it's going to cross our y-axis at -2. All right? So it's going to cross at our y-axis at -2. So it's going this way to the right forever and to the left forever. Okay? So that's a horizontal line. Okay? And lastly, our orange, x is equal to -4. That means it's going to cross our x-axis. You got that right? -1, -2, -3, -4. It would be right here. And again, that's a vertical line that's crossing here. Okay? So, that would be how you essentially graph each of these vertical and horizontal lines that we have here.